Okay, students, so today's notes video is on 10-3, generating equivalent expressions on page 14. So that's the only page that we're going to do today. And the topic is actually called combining like terms. Okay, so I'm actually going to write the topic right on top here. Okay, we're specifically doing combining like terms. Okay, now, so before I teach you how to actually combine the like terms, I need to talk about some of the definitions, such as terms. What are terms? We already know what coefficients are, and then also what are like terms, because like terms is very important. Okay, so first, talking about terms. Terms are parts of the expression that are separated by plus or minus signs. Okay, so then if you look at this very long algebraic expression, you have some plus signs. Unfortunately, it doesn't have any minus signs, but that's okay. Plus or minus signs. Okay, so then this 12 is one term, and then another term is the 3y to the second power, which is 3 times y to the second power. That entire thing is another term. 4x is another term. 2y to the second power is another term. And 4 is another term. So notice how all of these are separated by plus or minus signs. Okay, so if I were to ask you how many terms are in this expression, you would say there are 1, 2, 3, 4, 5 terms. If I say what are the terms in this expression, then you would say the terms are 12, 3x to the second power, 4x, 2y to the second power, and 4. Those are the terms in this algebraic expression. Okay, all right, the next thing that I want to cover is the coefficient. We already talked about what a coefficient is. Coefficient is the number that's being multiplied by a variable. Okay, so in here, there are only 3 terms that have a coefficient because these two don't have a variable attached. These are constants, right? So these have coefficients, and the coefficients are 3 is one coefficient. This one, 4 is a coefficient. And then for the last one, 2 is a coefficient. Okay, we already knew that. Now I'm going to talk about the most important definition for the lesson today, which is like terms. Okay, so I said these are terms. Now, like terms are terms with the same variable, but also that are raised to the same power. So that's very important. Something that even though the variable is the same, if they're raised to different powers, they are not like terms. For example, let's say I have 2x and I have 3x. Those are like terms because they both have same variable. But if I have 5x to the second power, while these two are like terms, this one is not like term because it is same variable, but it's not raised to the same power. Okay, so now, so I could have another one, 1x to the second power. Remember, x to the second power means the same as 1x to the second power. So then in this case, these two are like terms, and these two are like terms. But these are not like terms. Not all of those are like terms, okay? The reason it's important about the like terms is because if you have like terms, you can add or subtract. Okay, so I can combine these and say now I have 5x. 2 plus 3 is 5, so 2x plus 3x would make it 5x. Similarly, I can say together there are 6x to the second power. Okay, all right, now since I'm here, let me go over one thing that's very important. So let me actually change the problem around. Let me actually add some plus and minus signs. Okay, so pretty soon when we go back to our notes page, I'm going to teach you how I want you to circle or square, put a square around the like terms. So when you do that though, you always have to make sure, so here's 2x, and 2x and 3x are like terms, but I do not want you to box 3x like this. You have to box the sign that goes with the number behind it together. So the sign that's in front of the algebraic expression goes together. You need to box them together like this. This one doesn't have a sign, but you know that there is an invisible plus sign. It's a positive 2x, okay? And then I have another 5x squared, and then the x squared, those are like terms. But you want to make sure to circle the sign along with it. So here, you also want to put a box around the minus x to the second power. Don't just put x to the second power. This is very important. The reason is because it tells you whether you'll be adding them, the like terms, or subtracting the like terms. So if I were to solve this, this is gonna be the final answer. 2x plus 3x is 5x plus, now notice, 5x squared minus 1x squared. So this time you need to subtract. So 5 minus 1 is 4. So 4x to the second power. Okay, now there's one more thing. Not that this is incorrect, but when you're writing the answer, you always want to write the answer in alphabetical order. And if you have the same variable, but some are raised to different powers, you want to put the one with the higher power first. So I would actually rewrite this answer as 4x to the second power plus 5x. And that will be the best answer. Not that this is wrong. This is still correct, but this is the best answer. Okay, so hopefully that example kind of made sense, but we're going to do more coming up. Okay, so going back to our notes page. So let's take a look at what are the like terms in this expression. Okay, so remember, like terms are terms that have same variable but also raised to the same power. Okay, so over here I see 3y to the second power. But remember, you have to put the sign that goes with this number behind together. So you gotta go. Can you close the door, please? Okay. So plus 3y to the second power. And this one, plus 2y to the second power are like terms because both of those are y to the second power. Okay. Now, this one doesn't have any like terms. Okay. It's by itself. Okay. Now, but there's actually another set of like terms, and those are constants. Constants are like terms. Okay. Just the numbers themselves, those are like terms too. So I have 12. And then plus 4. Now, what's the point of doing this? Well, basically, we are going to simplify them or solve as much as you can, okay? So what you're going to do is this. You're gonna combine, add, or subtract anything that you can to condense this expression to as much as you can. Remember, just previously I said though, when you have multiple variables, you want to put the answer in an alphabetical order, okay? And then if you have same variable, then higher power first, which doesn't apply here. So let's write the answer. The final answer should look like this. Oh, by the way, and if you have constant, constant always goes at the very end of the expression. So, you know, in alphabetical order, x comes before y, and 4x didn't have any like terms, so then it'll just be 4x plus 3y squared plus 2y squared is 5y squared plus 12 plus 4 is 16, so plus 16. Now, take a look here. I don't have any more like terms. There's no variable with the same power. Okay, so this is my final answer. So my answer is 4x plus 5y squared plus 16. Okay. All right, so with that, we're gonna solve a few problems here. You see, it says simplify each expression. So watch my work expectation. First, write down the original problem. Second, I want you to circle. We're using different colors, so color code, or you can do, if you only have pencil, then you can like circles, one type of like terms, put rectangle around another type of like terms, underline another like type of like terms. You could do it like that too, okay? All right, so here, I have 6x squared and minus 4x squared. Don't forget to include the minus along with the 4x squared. Those are the like terms and those are it. So you can do 6x squared minus 4x squared is 6 minus 4. So the answer is 2, because 6 minus 4 is 2, x to the second power. So all you do is you add or subtract the coefficients, okay? And that's the answer. Here you go. Let's do another one. Number 9, right below. So 8y minus 3y. Well, they both have the same variable y, and they're both just raised to first power. They are like terms, so I'm gonna circle 8y, and I'm gonna circle minus 3y. That means you will be subtracting the coefficients. So 8 minus 3 is 5, so the answer is 5y. Okay. Now, let's go to the one right below. And now this time it has a little bit more variables. It has more terms. So a quick review. It has 4 terms. 1, 2, 3, 4. Okay. And the coefficients are 4, 2. Well, technically negative 2, but that's okay. Don't worry about that. 4. And then remember, if you have a variable by itself, it means there's an invisible coefficient 1. So this is 1b, okay? In fact, I'm going to write that 1 here. All right, let's circle the coefficients. Let's circle the like terms. So I see that I have a to the 5th power here and a to the 5th power here. Those are like terms. So I am going to box them. 4a to the 5th power, and then minus 2a to the 5th power. Those are like terms. I have another set of like terms right next to it. Plus 4b, let me use this one. Plus 4b plus 1b. Those are also like terms. So then let's, simplify them. Let's add or subtract their coefficients. So for these two, it says 4 minus 2. So you will subtract. 4 minus 2 is 2. So this is 2, a to the 5th power. You don't do anything to the variable and the power, okay? You only add or subtract the coefficients, okay? Plus, the next one says 4b plus 1b, which is 5b. Now, take a look at the answer. Did we do it in alphabetical order? Yes, I did. So that's the final answer. Number 12. So let's take a look here. I have 8m plus 14 minus 12 plus 4n. So notice, I don't have any of the same variables. So these two are not like terms, they're two separate ones. But I do have plus 14 and minus 12, and those are like terms, okay? So all I need to do is do 14 minus 12, and then clean up the answer. So since I'm gonna need to do it in alphabetical order, this is how I'm gonna write the answer. I know m comes before n, so I'm gonna write, just simply bring down 8m and bring down plus 4n, and then plus, now you need to solve this. 14, this plus also means positive, so positive 14. 14 minus 12 is 2. So then plus 2. 8m plus 4n plus 2. Here you go. Okay. Now, so 2 more problems left, and these are very important. Something that's different about these two than the other 4 that we did is this. Do you see that there is the distributive property? Over here too, distributive property, right? So something very important that I want you to write. If there is distributive property, do that first. This is so important. If you don't follow this instruction, you're going to get the problem wrong. So I'm gonna get my red pen, and I'm going to, hopefully this is very clear, okay? All right, so like I said, notice there's distributive property. So then you need to do that first. This is why I taught you how to solve the distributive property first, before I'm teaching this lesson. So you'll be doing 2 times 1b plus 2 times 5a. And then this one, what do? You simply bring it down. So notice how I'm writing the problem again, okay? So you're gonna bring down the 3a plus, and then now you're gonna solve, evaluate the distributive property. So 2 times b, remember b means 1b, so 2 times 1b is 2b, plus 2 times 5a, which is 10a. So you have to get out of your parentheses first by doing the distributive property first. Now take a look at the algebraic expression and see if there are like terms, and hopefully you do see the like terms. There is 3a and then plus 10a. So 3a plus 10a is 13a. And then you just simply bring down plus 2b. And that's the answer. Now, let's do one more practice. This is the last one in the notes. So again, I have this distributive property, 4 times x to the second power minus 4 times 1. So bring down the 6x to the second power plus, now 4 times x to the second power is 4x to the second power minus 4 times 1 is 4. Now, like terms. I do have these two like terms. 4x to the second power and then plus 6x to the second power plus 4x to the second power. Those are like terms. Now let's add them up. That's 6 plus 4, so 10x to the second power. Bring down minus 4, and that's the answer. Okay. All right. And that's it. So hopefully you got it. And I hope that you actually do review this lesson. Okay. All right.